I'd like to welcome Megan Grainger to the stage. Thank you.
Right. Hi, I'm Megan Grainger from Analytical Laboratories, and part of what I'm talking about today is data that has come from greenhouses on site, and I'm not allowed to point out Chris in the third row back, but she did most of the sampling. For the other part, it is data that has come from Carey Park, Midlands Apiaries, and Webster and Associates. So thanks to everyone that's helped put this together. So today we're talking about assessing the potential of your hive site. And when I started putting this together, I was trying to figure out what to talk about. So today we're looking at the frequently asked questions I will get when people are starting on the nectar testing. So we'll look at the different types of sampling. We'll look at some typical results that you get. We'll look at storing of the samples between getting them from your hive site to the laboratory and talk a little bit about fermentation. And then lastly, we'll look at variation, not only between the different methods, but also within trees and within hive sites. So to start with, what do I mean by assessing the potential of your hive site? We all know that we're striving to find the highest methyl glyoxal, or MPA, in our honey. And we also know that this varies between regions, between batches, within regions, and also between years. But we're interested in finding plants which are able to produce this high activity honey. So how does our site compare to, how does our site correspond to this honey? So as we know, dihydroxyacetone, or DHA, is present in the nectar of the manuka flowers. The bees take this nectar back to the hive site where it's converted to honey. Beekeepers then collect this, and over time when it's stored in the drums, this DHA converts to MgO, which we then correlate to the MPA. So if we look at a few samples of different varieties of plants, so not only do you now get Leptospermum scoparium in the white variety with the single petal, we also have pink petals and also double ruffle. So here's a few different varieties, and I'm not going to try and pretend I know which one is which. These are a few pictures I took in one of our greenhouses. So there's a lot of ornamental cultivars now, and Carey Park is doing a lot of work on a lot of the different varieties. So collecting honey is easy. We either scoop it out of the hive or we take it from the drum, but collecting nectar is a whole new ballgame. So first off, we want to be selecting flowers that have visible nectar, like this one you can see here. We don't want dead flowers. Now, you may think this is a bit odd to say, but I have actually received an envelope to the lab with a note saying, can you please test this branch for manuka? So in the envelope was actually a piece of manuka about this long, and about 4 days, obviously, after it had been picked, and needless to say, the flowers were shriveled up and there was not one single hint of nectar. So we want to be taking fresh flowers. And here's just a couple of examples of the nectar that you can see on the disc. So in some of these cases, it's droplets, and then others you'll get just a nice sheen of nectar across the whole disc. So at Analytica, we recommend 4 different sampling methods. So I'll step you through these, as this is quite a common question we get. So the first is directly sampling the nectar. So this is being the bee. We're taking a pipette and we're sucking the nectar directly off each flower into a tube. And to make one sample, we take nectar off 10 different flowers into this single tube to send to the lab. So the advantages are we obviously have 100% nectar, and it preserves the flower. So for us, that was quite beneficial in the greenhouse because our trees were not too big and we didn't have a heck of a lot of flowers on them. Disadvantages are this is quite time consuming and it's less practical in the field for collecting large volumes of samples, especially when you've got very tall trees. However, over my Christmas break, I took a pipette from the lab and I was doing a bit of sampling while I was on holiday, and I had a few of my cousins' kids trying it out. So it is actually quite an easy technique, and they actually quite enjoyed it, and we got some good results out of it. So the second method is the pipette method. So this is also what we call the 10 by 10 method. So we're taking 10 microliters of water onto an individual flower and dissolving the honey, and then sucking this back up and putting it in a tube. And we repeat this for the 10 flowers. So therefore we have 100 microliters of sample. So we've got sufficient sample for testing. And at this dilution, the DHA and the sugars generally should be at measurable levels in the laboratory. However, once again, it's time consuming, possibly more time consuming than direct nectar, because now we're adding the element of putting the water onto the flower and taking it off again. And once again, it's less practical in the field for large volumes of samples. And we have to take care when we are trying to dilute the nectar in this water that we're not scraping the disc of the flower with the pipette tip, as this could cause damage to the flower. So the third and fourth methods are very similar, and these are our tube wash and our soak methods. So this requires plucking 10 flowers from each tree to make a sample, and these go into a tube, if it's the tube wash method, and add 1.5 mils of water, give it a good shake to dissolve all the nectar, and then decant this into a tube to send to the lab. If we're doing the soaking method, we're required to pluck off all the leaves and the petals, as you can see in that top corner. So this takes a little bit more time. Then all of these go into the water and soak for 20 minutes before decanting the liquid out. So the advantages of these two methods are they're nice and quick and easy. You can rip your flowers off the tree and chuck them into your tube, no worries. So this makes it highly practical in the field for large volumes of samples. And there's also sufficient sample volume for testing in the laboratory. So as I didn't mention, sometimes for the direct nectar, depending on how much nectar those flowers you're choosing are actually producing at the time, we may get maybe 5 microliters, if not 2 microliters to test across those 10 flowers. So it does make it quite difficult when we're testing in the lab. The only disadvantages of soaking for this long is it may extract extra sugars into your sample, and this may sometimes cause an interference when we're doing the chromatography. But we haven't really seen too many cases of this. So what is nectar made up of? As we know, it's the flower is trying to attract the pollinating insects, so it's going to be nice and sweet. So we've got 80% sugar, give or take, so about 40% glucose, 40% fructose. There's also about 2% sucrose in there, and then the other major component is about 20% water. We also have other compounds at lower levels, so we've got our DHA and our leptospirin, which are unique to our manuka, which we're interested in sampling, but we also have a majority of other compounds here that are transferred from the nectar to the honey, and these may be good markers for knowing that we're looking at manuka. So once it comes into the lab, what do we do with it? We take it and we use HPLC, or high performance liquid chromatography, to separate out the compounds that we're interested in. So up on screen you'll see highlighted here the DHA peak, and it's been separated away from the other sugars, and we're doing this by UV detection. We also look at the leptospirin, so this is a nice strong peak that we detect by fluorescence detection. And then lastly, we have our sugars. So we're only looking at glucose and fructose, but due to the method, we take a derivatizing agent, and this joins on to the sugars so that we can see them by UV detection. And depending on what way our derivatizing agent joins onto the sugar, we get a raft of isomers, as you can see here. So as we've talked about, you know that we have 3 different volumes of sample depending on what method we've used, so we can't directly compare 100% nectar with something that has had a tube wash with that 1.5 mils of water. So what we need to do is normalize our results so that we can compare them. So we know that honey is about 80% sugar. So what we do is we normalize the DHA and the leptospirin to the sugar that we've found in the nectar, so that we're looking at 800 grams of sugar. And this will give us our relative milligrams per kg that you would find in the honey. So instead of talking about normalized DHA being milligrams of DHA in 800 grams of sugar, I'm just going to, for ease today, just say milligrams per kg, because they're more or less equivalent. So for a sample, this milligrams per kg would be what you would find in a honey that was solely derived from the nectar that we've just tested. But how does this compare to the actual honey? So in 2009, an article was published by Adams, Manley Harris, and Molan, who took their highest pink nectar and converted this to a crude calculation for what you'd find in the honey based on this sample alone. And they found that it was 13,600 milligrams per kg. So all of us here would know that this is a lot higher than what you would actually find in a real honey. So therefore, I went and had a look at what our spread of DHA was in nectars that we've tested in the lab. So in 1,300 samples, you can see our frequency graph here. And for a few numbers, so our average is about 3,800. So this typically would actually be quite a high honey sample, but for the nectar, it's not too bad. Our maximum that we found in this set of data was 27,000 milligrams per kg. So this is huge, and you can see there's not too many samples that we tested up in this region. Interestingly, only 12% of the data we tested was below detection limits. So this shows that the sampling methods are working well. So in the cases where it was below detection limit, maybe because you didn't have enough nectar on your sample, or it was diluted too much during testing. If we compare the spread of DHA from the nectar to what we get in a honey, so from data that we've tested, I filtered out just, 3,600 samples. Now, I have no idea where these samples come from or whether they're a Manuka blend, or a non-Manuka. So I filtered them to have over 100 milligrams per kg of DHA, so that they should be a Manuka sample, even though they may be a blend. And we looked for honeys that had less than 4 milligrams per kg of HMF. So we're looking at, give or take, fresh honeys. And you can see the spread is an awful lot lower than what we were finding in the nectar. So our average is only 980 milligrams per kg, and the maximum is only 5,300. So if we compare this back with the nectar and we overlay it, our average from the nectar is actually 5 times higher than what we're seeing in the honey samples. So reasons for this may be that your honey has been diluted by other Manuka, which doesn't have, that has come from trees that aren't producing as much DHA, or it may be because of different floral sources are also diluting it. We also know that not all of the DHA will convert into the honey. It may be utilized in other pathways. So this is also a reason for the dilution. So what do we need to consider when we are sampling nectar? We need to think about the method we're using and whether there is actually nectar present on those samples we're taking. We need to make sure that we've got a representative sample. We also need to think about the age of the flower. I've heard that the newly opened flowers, such as the one you can see in the top, don't actually produce nectar straight away, and it takes, I think it's about a week to actually start producing the nectar. So you've got to think about which ones you're plucking off. We also need to think about when we're sampling what's going on in the environment. Have we just had a massive rainstorm and so all our nectar is washed away or diluted? Is it too cold? I've also heard that Manuka will not produce nectar if it's under 23 degrees. So I'm not sure if this is all samples or all plants, but it's just hearsay at present. We also want to think about the soil type and how much stress is this plant under. Likewise, I've also heard that the more stress, the more DHA that is going to be caused, but unfortunately I can't back this up with any peer-reviewed publication just yet. And we also want to think about fermentation of the samples before they get to the laboratory. So you might be out on the field for the day collecting a lot of samples, and you might just chuck these back in the truck, and they might be sitting there, and it might get quite warm. So what we did in the laboratory was we took a nectar sample, split it into two, diluted one with water and one with 10% methanol. We then took this and stored it at 27 degrees for 5 days and tested this each day over the course of the day to see what was happening with the results. And this was to simulate samples that were kept at room temperature while sampling, or also in transit to the laboratory. So superficially, it looks like we're actually increasing the normalized DHA. The graph on the left shows the sample that was stored in water. So it looks like there's a trend for it to go up, whereas the one on the right shows that there's not too much variation. However, how can we be creating extra DHA? So it seems a bit weird. So if you look further into it, we analyzed the DHA and the leptospirin and did not convert it to the normalized result against the sugar. So if you look at these two, everything is very stable across the week. So there's no change in DHA or leptospirin. So what is really going on? So if we look at just the sugar concentration that we're getting over the week, we're seeing that the sugar is actually decreasing, and this is due to fermentation. So when we then normalize the DHA, we see an increased result artificially for the DHA. So variation on a tree does vary a little bit. So we took, on one day, we took between 3 to 5 samples, depending on how many flowers we could get off a tree. So we've got 7 trees here, and we saw a little bit of variation, but less than 25%. So if we compare this to our 3 sampling methods for normalized DHA with our pipette method, our tube wash, and our soak, we're also seeing less than 25% variation. So you know that the 3 methods are in good agreement with each other. Likewise, we saw this for leptospirin. Over the course of an entire month, we saw there was variation over that one tree. However, the 3 methods are once again in good agreement with the variation. Out of interest, we marked 10 flowers on one tree and sampled these using the 10 by 10 pipette wash method for the course of a week, and you can see that over time these flowers didn't actually regain their nectar, so we're not entirely sure why this is happening. And as you can see on day 6, we still have a DHA reading, but by this point our leptospirin wasn't present anymore. So the next big question is, what is the variation over a hive site? And the question we want to answer influences the way we're sampling. So are we a nursery? Do we want to find the best manuka plant that will produce the highest DHA we've ever seen? Or are we a beekeeper and we want to know if we've got a good hive site? Or are we a landowner and we want to see if our manuka plants need to be ripped out and we need to start again with higher ones? So what we need to do is think like the bee. So I was asked by a client, they had limited money, they said, if I take one flower from 10 different trees and put these into one sample and sent it to you, would I get a result? Yeah, of course you'd get a result, but is this really telling you a lot? What about if we took 10 flowers and put them from one tree, put them into a sample, and then did this for 10 different trees, and then took equal proportions of these and made a composite. Instead of now having a representation of 10 flowers across your hive site, you're going to have 100, so you're getting more results. Ideally, if you took your 10 flowers for each sample and you individually tested them, you're going to start to build up more of a spatial awareness of what's happening on your site. So if we just run through a couple of slides, you can see that if we composite them, so the composite is in the red line, and the green line is an average of the 10 different trees across the hive site. So there's only 2% variation. So value for money by chucking them all in together. This is not always the case. So in this particular site, 6 of the 10 trees were below detection limit. So by the time you take a composite, it changes 62% different to the average. And then, because I'm conscious of time, I'll just quickly flick to this one here. This hive site only had 2 results above detection limit. And if we had have taken equal proportions of all of these into one sample for the test, this composite result would have given us below detection limit. So we would have thought, okay, this site has no useful DHA producing manuka. However, by taking each sample individually, we actually see that there's 2 really good trees. And in fact, that one at the very top, that's the 27,000 milligram per kg. So that was the highest one we actually saw in all samples tested. So therefore, you'd want to go back to your hive site, grab that one, and quite possibly clone it. You can see here, this was 44 different samples over an entire hive site. And you can see that you can get a bit of a spatial awareness of what's happening, and you can build up more of an average of what your honey might be doing. So, last slide here. So we've got factors that we're considering. We have our results, but what are they telling us, and what are we going to use them for? So we need to think about the site. How many other trees are giving us results the same? And if we've got non-manuka plants present. We've also got to think about the trees. How long are they flowering for? Is it just the typical 4 weeks, or are they a new breed and they flower for longer? Do they have high density flowers on the tree? And how much manuka is it producing? It's all very well to have a very high producing DHA tree, but if it's giving you very tiny amounts of nectar, the bees aren't going to be too interested. And we also need to think about, if we're trying to take a really good tree from Northland down to Southland, is it going to cope? Is it going to be resilient? So there's a whole lot of factors we need to consider. And because I know time's up, I'll skip over the summary. And I'd just like to give a big thanks to Midlands, Apiaries, Carey Park and Webster Associates for sharing their data, not only with myself, but with all of you here today. Thank you.
Megan, we do have time for questions as well, so if they want to come on up. But also, you might want to just, you've got a few minutes, so do you want to go through your summary page again? Yeah, we've got more time.
So virtually, it was just in a nutshell, recapping everything. So the different sampling methods that we talk about give us very similar results. So it depends on whether you're out in the field and you just need to rip some flowers off your tree, or if you're in a nursery and you've got very limited flowers like we did, so we didn't want to be pulling all our flowers off the tree. We would have finished our experiment in about 3 days, which I'm sure Chris would have been happy with, as she struggled to keep some of them alive. I think it was from overwatering, and I think they prefer to be neglected. We also know that the normalized DHA in the nectar is at least twice as high as what you'd see in your honey, so don't expect to get your 27,000 milligram per kg tree and then get your bees to collect off that and expect the same in your honey, so it is definitely going to be lower. We've talked also about the results will depend on a number of factors, such as the type of tree, your environment, and your sampling procedure, so you do have to be careful with that one. And likewise, we've seen how much variation you can get over the course of a hive site, and what questions you have and what answers you're wanting will dictate the way you're going to sample. So there you go. Thank you.